So let's work on these. I'm going to say that, so part A is probably harder than part B. So I'm going to give you a few minutes to work on this. Try to do part B first, only because I think it is a little bit easier. And then try part A after that. So now you kind of know the deal with the L'Hopital's rule, right? First, you need to check, do I get 0 over 0, right? Or infinity over infinity. If yes, you can continue with L'Hopital's rule. You have the option of doing that. And L'Hopital's rule says, okay, do derivative of top and bottom, and then keep on going, right? And I'll leave the solution to the previous problem there as well, so you can kind of see how it works. All right. I never even asked how you guys are doing. It was an exam night last night. How'd this exam go? How'd we do? How'd it go, Thomas? One question, 27 parts. Did you like that? It was 8 parts, technically, but wasn't too bad. You know, the other exams were also not too bad. Maybe you guys are just doing better. You think it could be that you guys are just getting more used to everything and just doing better, and you think it's like that, or the exam was actually easier, or hmm, combination. You guys ever heard of attribute bias? Have any of you ever heard of that? Attribute bias? Okay, so again, if we substitute the relevant value of x, we get 0 over 0, right? X equals pi over 2, and my cosine of pi over 2 is 0. So I do get 0 over 0 for both. So first, let me just kind of repeat what we said last time, right? So we're allowed to use L'Hopital's rule. Okay, so let's look at part A first. Okay, so L'Hopital's rule says I take derivatives of top and bottom separately. So up top, I get negative sine x, and down below, I get negative cosine x. And how would you like to proceed with this? So clearly, if I substitute pi over 2, what did you get when you substituted pi over 2? Did you get up to this? What do you get when you substitute pi over 2 coming from the right side here? You get 1 over 0. What is that? Yeah, 1 over 0, negative 1 over 0, depending on whether you actually, cancel out the negatives. So what does that actually imply? That is an undefined expression, but so is 0 over 0. But 1 over 0 implies something different than 0 over 0. Right, it implies a vertical asymptote. So I'm very familiar with the tangent function. Are you familiar with the tangent function? So negative sine of x over cosine of x is the same thing as tangent of x. So I'm going to look at the limit like that. So how can I actually go about calculating this limit? Well, I know what the graph of tangent of x looks like. So let's look at that instead. So for instance, I do know that tangent of x has these vertical asymptotes. I'd say x equals pi over 2. Actually, all the odd multiples of pi over 2, right? That's where tangent of x has its. So does everyone should be familiar with this graph, right? With tangent of x, right? You should at least understand where the vertical asymptotes are and just the general shape, right? Tangent of x is not too difficult. So Kevin says it's negative infinity. Exactly. So if I read off from the graph, I'm approaching pi over 2 from the right side, I can see from the graph that it goes down to negative infinity. So that would be my final answer here. So from the graph, we see that this limit is actually just equal to negative infinity. That's good. There are other ways you could have actually done this, but they all involve some sort of sign analysis. They all do involve it coming down to, oh, this is a vertical asymptote, and that's it. So, I mean, is there a way to do this without the graph? I mean, you don't need a graph. You can also just know what the values of tan of x are beyond pi over 2, right? I mean, I know once you realize that this is a vertical asymptote, what do you have to do? You just do a sign analysis, right? So you need to substitute a value of x that is just beyond pi over 2 to see what happens. And what is the tangent of an angle just beyond pi over 2? So you should know that that's negative. So therefore it's negative infinity. Right? You can also do the same thing over here with negative sine of x over cosine of x. You can plug, so first of all, I'd cancel out the negatives. You can plug in a value of x that is close to pi over 2, but on the right side, right? So sine of pi over 2 is 1, and the cosine of an angle that is just beyond pi over 2, right? Again, think about what does that mean? That means if you're looking at the unit circle, I'm looking at an angle in the second quadrant, just barely in the second quadrant. And I know that in the second quadrant, the cosine is negative, right? So I get 1 over 0, but a negative number. So again, I get negative infinity. So in either case, you have to do some sort of sign analysis, right? Do not forget your techniques from the beginning of the course with vertical asymptotes. Vertical asymptotes always come down to a sign analysis of the top and bottom, right? In this particular case, I thought, you know what, let me just look at tangent of x directly. Let me not do that because, I have that advantage. All right, now let's look at part B.